Why gravity cannot be emergent in a terrain-based universe. This section exists to remove a recurring objection before it derails the rest of the framework. The objection usually takes the form of emergent gravity, the idea that gravity is not fundamental, but arises from collective behavior of matter, information, entropy, or microscopic degrees of freedom. This paper does not attack that program, name researchers, or dispute its mathematical ingenuity. It makes a narrower, structural claim. In a universe where space-time geometry functions as a real terrain that constrains motion globally, gravity cannot be emergent from matter alone, without quietly assuming the very structure it claims to derive. The core issue is coherence. Gravity operates as a globally consistent constraint. It applies everywhere at once with the same rules. Trajectories separated by vast distances remain mutually consistent over time. Light, matter, and free-falling observers agree on curvature effects, even when they never interact. Any emergent explanation must therefore explain not just local behavior, but how a single, unified gravitational architecture appears prior to and independent of coordination between occupants. This is where emergent from matter models encounter a structural problem. Emergence, as used successfully in physics, typically describes local order arising from many interacting components. Temperature emerges from molecular motion. Pressure emerges from collisions. Elasticity emerges from bonding networks. In all such cases, the emergent property depends on pre-existing space, time, and interaction rules. The container exists before the contents organize. Emergent gravity proposals invert this pattern by attempting to derive the container from the contents. In a terrain-based universe, that inversion becomes logically unstable. To see why, consider what would be required for gravity to emerge from matter alone. Matter would need to interact according to some rules in order to generate large-scale curvature. Those interactions would have to occur within a space that already supports distance, adjacency, and causality. They would also need to produce a geometry that is smooth, continuous, and globally consistent across regions where matter has never been present. The problem is not that this is impossible in principle, but that it presupposes structure at every step. The interactions require geometry to be meaningful. The coordination requires shared temporal order. The resulting curvature must already obey the constraints it is claimed to produce. This leads to circularity. If gravity emerges from matter interactions, those interactions must already occur within a framework that enforces consistent paths, relative acceleration, and signal propagation. But those are precisely the roles gravity is supposed to explain. The model ends up assuming an architectural substrate in order to derive an architectural substrate. The emergence explains modulation, not origin. The terrain-based universe exposes this circularity because architecture and occupancy are cleanly separated. Geometry exists as constraint. Matter enters and responds. Matter can modify the terrain locally, deepen basins, sharpen gradients, or smooth regions, but it does not summon the terrain into existence. Trying to make architecture emerge from occupants is like claiming that roads emerge from traffic. Traffic can wear grooves, widen lanes, and create congestion patterns, but it cannot create the map on which it flows. Without roads, there is no meaningful traffic behavior to aggregate in the first place. Global coherence sharpens the issue further. Gravity does not emerge piecemeal. There is no region of space-time where gravity is still computing itself, while elsewhere it has settled. Gravitational behavior is consistent across empty regions, sparse regions, and dense regions alike. Light bends where no matter resides. Geodesics are defined where no particles travel. Any emergent account must therefore explain how empty space inherits fully formed gravitational behavior without matter present to generate it. In a terrain-based view, this is trivial. The terrain exists, whether occupied or not. In an emergent from matter view, it becomes an unresolved dependency. None of this denies that matter affects gravity. General relativity explicitly allows matter to influence curvature. What it denies is that gravity can be reduced to matter alone, without remainder. Influence is not origin. Modification is not generation. Treating gravity as emergent from matter collapses that distinction and obscures the role of pre-existing constraint. This paper is defensive by design. It does not seek to win debates or close research programs. It exists so that the other sections do not have to repeatedly justify why gravity is treated as architectural rather than emergent. Once architecture is acknowledged as primary, emergent phenomena can still exist at higher levels, but they occur within structure, not in place of it. Gravity, in a terrain-based universe, is the rulebook that makes emergence possible, not a consequence of emergence itself. The difficulty emergent gravity models face in a terrain-based universe is not primarily empirical but structural, and that difficulty is already visible within established physics. General relativity treats gravity not as a phenomenon that appears when matter organizes itself, but as a geometric condition that exists wherever space-time exists. The theory does not describe gravity as something that turns on once sufficient matter complexity is reached. Instead, it defines curvature as a field that can exist in vacuum, propagate through empty regions, and constrain motion regardless of whether matter is present. This formulation, originating with Albert Einstein, already places gravity in the category of architecture rather than emergence. One of the strongest supports for this view comes from vacuum solutions and gravitational wave propagation. Space-time can possess curvature and dynamic behavior even when no matter is present locally. Gravitational waves travel through near-empty regions and retain coherence across vast distances. If gravity were emergent from matter interactions alone, there would be no mechanism for fully formed gravitational behavior to exist in regions devoid of matter. Yet both theory and observation confirm that it does. Geometry does not wait for occupancy. It persists independently. Emergence, as a scientific concept, has well-defined boundaries. Emergent properties arise from many body interactions operating within an already structured framework. Temperature emerges from molecular motion, but only because space, time, and interaction rules are already defined. Fluid flow emerges, but only because geometry and boundary conditions exist first. In no established physical system does the container itself emerge from the contents without presupposing the container in some form. This is not a philosophical objection. It is a pattern constraint observed across successful emergent theories. Attempts to derive gravity as emergent from matter must therefore assume pre-existing notions of locality, adjacency, causal order, and trajectory in order to define the interactions from which gravity is supposed to arise. But these notions are exactly what gravitational geometry provides. The moment interactions are defined in a way that allows global coordination, a shared metric structure has already been assumed. The emergence then explains modulation or effective behavior, not the origin of the architectural constraint itself. Global coherence further reinforces this limitation. Gravity behaves consistently across regions that have never exchanged information or matter. Distant, free-falling observers agree on curvature effects without coordination. Light propagates along null geodesics that remain well-defined even in empty space. These facts require a unified geometric framework that applies everywhere simultaneously. Emergent models built from local interactions struggle here because local emergence does not naturally yield instantaneous global consistency without an overarching structure enforcing it. Importantly, established physics already distinguishes between influence and origin. Matter influences curvature through stress energy, but curvature is not reducible to matter content at a point. The Einstein field equations relate matter and geometry, but they do not collapse geometry into matter. Geometry remains a primary object in the theory. Treating gravity as emergent from matter alone removes that distinction and introduces explanatory circularity without improving predictive power. None of this rules out emergent descriptions at higher levels. Effective gravitational behavior, thermodynamic interpretations of horizons, or information theoretic analogies can still be useful. What it rules out is the idea that gravity itself, as a global architectural constraint can be fully derived from occupants without assuming structure first. In a terrain-based universe, gravity is what makes emergence possible, not something that emerges afterward. This supporting logic allows the framework to acknowledge emergent approaches respectfully while explaining, in grounded scientific terms, why gravity must be treated as fundamental architecture rather than a late-arriving collective effect.